time we talk about two embedded system design. One is measure the temperature and humidity, right? And we also say hello to our IoT development board, right? Like a blinking LED, and we can make it fast or make it slower. So today we are going to talk about relays. And relay is a mechanism which was used almost everywhere. For example, you want to turn on the air conditioner, you use remote control. And you send a message, you send an IR message to the air conditioner. Actually, the receiver will turn on relay so that the AC power will flow into the air conditioner and turn the circuit on. Similarly, if you want to turn on the TV or a lot of, almost all the appliance, if you have remote control, is do something like this. Okay, and also for the microwave, even they do not have remote control. You push a button, actually you turn on the relays. So relay are used everywhere. For example, electrical current, right? You want to turn the motor on so that the motor would, will either shutting off the current or maybe open the current for you to. So these are all used relay. Or for example, electronic door lock is also used relay to turn the motor on so that door will be open and turn it off, and then the door is closed. And you can see a bunch of gauges in sedans or a car. You can see a lot of buttons that turn on and off relays. And sometimes another kinds of relay called solenoid valves. They turn on like gas or like gas pump. And when gas pump, the oil. You say yes. Gas in French, right? Okay, and or maybe like a natural gas. Similarly, they can turn something on and something off. And also electrical car, home appliance, they all use relays. So relay are used almost everywhere. And relay is an electrically operated switch. So for example, basically consists of two loops. One is control circuit or control loop, and the other is load circuits. So for example, we have an AC circuit here, and this is DC or small currents. So if we somehow electrically short these circuitries, then they will this is coil, and they will have generate magnetic power, right? So they kinds of attract these ions to here, and that will push to this guy, so that this become a circle or a loop. And when it is a loop, then you provide power to this load. It could be a TV or could be an air conditioner. So when you do not supply power here, and this is open or break, so there's no magnetic in this coil. So this point and these points are not become a loop. So there is no power, in this circuitry. But when you switch it off, then they become connected. So the magnetic power actually it will be will withdraw or attract this ion here, so that they will touch this one, so that your appliance or relay actually, this is relay actually. So the relay actually that the larger current like this is 110 volt or 220 volts AC currents flowing to this loop. So usually you can buy just one single relay, like our board here, right? And you can have maybe 2, 4 relay modular, or maybe 8 or 16 relay modular, especially used in hospital. They probably need 16 relay modular, so that they can control almost everything in the hotel rooms. And there are three point here, and they were marked as normal close and normal open, and the center one is common. What does that mean is consider this was a pair or loop. What the normal close mean, when you do not apply any power, and these two are connect, in default. And the normal open mean, when you do not supply power, these are disconnected. So what does that mean is, if you apply some kinds of voltage here and turn this relay on, then the normal open and the common part will be connect together, and the normal close will become disconnected. So it depends on do you supply power or not. And usually if we we want to kind of separate from the strong voltage from our maybe we say it's a small current digital circuits. Usually you will use a photo transistor. So in this kinds of photo transistor, you can see that if I emit, if I have power to go through here, then they will emit some LED light. And this photo transistor, so when they receive the photons, then it become connected. So they use these kinds of circuitry to separate from these heavy current circuits. Separate is from the small circuits, and this is called photo transistor. So anyhow, you can just think that if I apply one, say suppose right now we have a 4 relay here, right? And it should be this is control the first one, okay? And if I apply one here, then these two will be connected, and these two will be disconnected. If I apply 0, then these two will be connected, but not these 2 points. So similarly for the rest of the relay, they operate in the same manners. So how we are going to say, like building a smart plug. A smart plug means, when you detect the light is too dark, then you automatically turn your light on, something like that. So when we say smart plug, actually we do have smart plug. I'm not sure do you see them in the demo room. We have a white box, and there are four plugs. Do you? Yeah. Okay. So yes, and inside this, actually we add one more module, which is called power measurement module. So not just you can switch something on and off, but you can also measure how many power the power consumption, something like that. So okay, so did you bring your bowl? No, maybe you should bring your bowl. Say suppose I connect to this guy, and I want to try some things. And first you have to understand which pin connect to the relay, right? So maybe we should so to use relay, you have to understand which pin actually connect to the relay. And in this document, we can see that actually, where's my mouse? Actually, you can see that the pin 8 here, actually connect to the relay, right? And when we say relay, we want to do the control, right? It's kinds of actuator. So we have to go to the actuator instead of sensor. And later you can see that if it's too dark and turn on the light. So how are you going to measure it's too dark? We have a photo sensor here. It is already connected to the A0. So the A0 here connect to the photo sensor. So if we detect light is too dark, we can turn the relay on. Okay, something like that. Oh, okay, you already did that. Yeah, great. The LED is not too bright, but you can really put in AC lamp. So something like that. Okay. Here we have to say that this should be connect to the 8, right? Pin 8. So if we want to just try it out, we can say we set the relay pin, which is A, as output pins, and then we can write high and write low, and then we can use maybe meters to just measure in this port. Do they connected or do not, or they are disconnected? So in this way, or you can maybe just add like a circuitry here. So here this is our no MCU, and in the no MCU we use D8 to connect to the relay. So this part is the relay. So we should be draw this way. This part is our relay. Okay. And then we connect in this way. And we have this is called male plug, maybe male plug. And if you connect this way, so one of the male you connect to the common. Okay. And the other side you connected your lamp. And you can see maybe we can have a female plug here. Okay, some kinds of female plug. You can see this is male plug, and this is female plug. Okay, and then this is common, right? So the middle one is common. So one is connect to common, as I show here. This is common, okay, and the other go through the the other part, and they connect to the female. This is the kinds of female plug here, and then another from the female plug you connect to the normal open, because you don't want to in default it will be closed. Not close, disconnected, so that the light will not go on. So if you detect if the light is too dark, then you switch this become 1, and they will emit the LED light. So they will change the coil, the coil, and they would some kinds of flip this iron to this to this way, so that they become connected. Okay, so So you can just use high and low to turn the light on or turn the light off. And I guess Jonathan already used the ambient light sensor. Okay, I guess you use. So did you use the light ambient sensor too?
I think so. I don't remember.
So it's just very easy, because they connect. There is only one ADC pins, so there is no need to choose the pin. Actually, only pin 0. So in our block, you just use ADC.read, and there's only one pin. But for the ESP32, you have much more ADC and DAC pin you can read or write on. But in ESP8266 there is only one ADC pin, so you just use pin 0. So here is you set pin 0, and then you have a timer to read the lightness. Okay. So smart lighting is something that you select the illumination. If the light is not good enough, then you turn on the the light, the lamp here, something like that. Or like Jonathan, turn the LED on. So how are we going to do it? And the embedded system is quite easy. So let's see. So maybe enlarge a little bit. Block size. It's so big already. Okay, so first we create a project. And then we try to use the actuator. So we set pin A as the output pin because we want to turn on or off the relay. And then we probably will use write 0 or write 1, So we just drag this one. Okay, so that go back to the no MCU. So we need a timer, right? And we probably need to understand, this turn on and turn off, right? So we need to align to tell us where to turn on or turn off the light. And the light is in the sensor part. And there's only one pin, is something like a re-analog pin. And if you put it here, you can see that they will automatic, do the ADC and read 0 for you. Since there's no pin to select, something like that. So okay, so you read the value. Maybe you want to print something out and see if everything is correct or not. So kinds of debugging. So you will say a line equal to this value. Then you use just if then else. Right? You say if the value usually you got from 0 to 123. So you will see that if so for example 512, maybe if this guy less than 512, then you would turn on the light. So the light right now is at pin 8, right? So we turn on the lamp to hide. Otherwise, I would just turn it off. So it should be kind of easy in this way. So we put it here, and we will save it to maybe smart lightning. And then compile the code. Okay, sorry, I have to drag and drop the value here. Compile the code. Okay, now it looks fine. So then we export. We export it to the ESP8266 like this. So we connect the board. Then we send this to ESP8266. So you can see that the line right now is 832. So if I make it a little bit darker, so you can see there's some called chart, right? So if I put it, I would make it larger than 100, and you see that there's a sound, right? That is, I apply a power, and the power actually is magnetic power. So they attract the ions. So there's a switch, and when I turn it off, and they switch off. something like that. So I guess you can try this one.